Hello everyone, today we're going to be going through answers from 4.1 homework, and you guys can see in Classroom that I've already posted the full answer key to this section. What I want you guys to do is go through and fix the problems that you've got wrong. Now, for most of the questions, those use simple formulas and have pretty straightforward answers, but there have been a few that have consistently proven to be difficult. So I'm going to walk through those ones and you can follow along and mimic the work that I do on here for your corrections for those ones. If you already know some of the ones on this video, feel free to skip around. I will circle the problem number while I'm working on it so that you can easily see which one I am working on and skip to that one, and I will cross it off when I am done. So let's start with number 13. Number 13 asks for these two angles. And when I'm trying to solve that, what I'm going to be doing first is just looking at what markings I have and what angles are given to me. So first off, I know that this is 140 degrees. And since it's an exterior angle, it forms a linear pair with this interior angle right here, that angle I. So that means that this angle plus 140 is going to equal 180. So I plus 140 equals 180. So I can subtract 140 from both sides, leaving us with I is equal to 40. So that means I have 40 degrees here. And that is the KIH for my answer. Since these two angles are congruent due to those markings, that means that the angle H is also 40 degrees. If I look at then what K would have to be, well, what I can find is a formula using the interior angles of a triangle. I know that all three of these angles on the inside add up to 180. Therefore, my angle I, 40, plus my angle H, 40, plus my angle K is going to equal 180 degrees. Well, that means what I really have is 80 plus K is equal to 180, or just K is equal to 100 degrees. For our next one, number 14, I'm going to kind of start with the same process, but this time I'm going to look at what measures are given to me and realize that, hey, I don't have any actual measures, but what I do have are three angles given inside of a triangle. And as soon as I see that, that means that I can use the formula for the sum of the interior angles of a triangle. And that tells me that T plus R plus S is going to equal 180 degrees. So I'm going to substitute in the 2x for T plus the 2x for R plus the x for S is equal to 180. And then I can add these together. So this will give me 2 plus 2 plus 1x, giving me 5x is equal to 180. And that means that we now have our x. And with this, once you have x, you can go ahead and fill it in for each of these. Now, we know that we divide both sides to get our 36 here. So then s would be a measure of 36. 2x will be double that, which will give you your measure of 72. And if you want to solve for r, don't forget that these form a linear pair, and that should get you through the rest of that problem. So let's then go to number 15. When we're working through 15, I'm going to look at what overall pattern I have. Now remember, with the options of formulas I have one that gives me a linear pair with an external angle, which would be helpful, except notice there's nothing written here, so that's going to be difficult to get. I also have the sum of the interior angles, which also I'm missing this angle, so I can't use the sum of the interior angles. And last but not least, with the exterior angle, I know that the exterior angle is equal to the sum of these two angles, L and M. So that means that that is a formula that I have something to substitute in each term for. So x then is going to be equal to the sum of L plus N, or x minus 60, plus x minus 20. Watch your algebra here. The negative 60 plus a negative 20, when you're combining your like terms, gives you negative 80. And x plus x gives you 2x. Here I'm going to add 80 to both sides, so I have a positive value. And subtract x from each side to get that 80 by itself, and that leaves me with 80 is equal to x. So now that I know what x is, I can again substitute it in for each of these and find the final answer for this problem. Our next problem, number 16, follows in a similar sort of setup. What we're going to be doing is looking at what angles it's given us. Now it's given us this angle, and this angle here. And since I now have 3 angles marked on the interior of my triangle, that means that the formula I want to use is for the sum of the interior angles. So 180 is going to be equal to t plus u plus b, or x minus 20 plus x minus 40 plus x, each of those angles added together. Here I'm going to combine like terms. This leaves me with 1, 2, 3 x's, and negative 20 plus a negative 40 gives me negative 60. At this point, we have a simple formula to solve, so go ahead and add that 60 to both sides. And that leaves us with x is equal to 240 divided by 3, or x is equal to 80 once more. Once you have that, again, you can solve for anything else it might ask for. Don't forget that if you're looking for this angle right here, this exterior angle, it's going to make a linear pair with our x value here, which means that if x is 80, so this angle right here is 80, this exterior angle next to it will have to add up to 180 when we add it to that. Therefore, it must be 100. So that's the end of 16. For this next section, 24 to 29, most of the questions boil down to the picture that you draw. So what you're going to want to do is really try to ignore any excess information. So for 24, if I'm only dealing with angles within AEB, the triangle AEB, and I know I'm only dealing with it because those are the only 3 vertices mentioned, why not copy down just this triangle and fill it in according to the information that it gives me? But the other question that tends to throw people off is number 29. So it wants to know what is the measure of all 3 of these angles added together. Well, if I draw these 3 angles in, I have D to B to C, so this angle right here. I have B to C to D, so this angle right here. And last but not least, I have C to D to B, so this final angle. Well, if I look at all 3 of these angles, notice that I've drawn a full triangle. That means that the 3 angles inside must add up to 180 degrees. So they found out it's 180 degrees because we have 3 angles within a single triangle. For 37, what you're going to have to use is a few ideas from previous sections. What I'm going to be doing is filling in as many things within one triangle as I can. First off, when I see 2 triangles linked, one thing that I notice is that these 2 things form linear or vertical angles. And since they form a vertical angle, that means the measure of this one is going to be equal to the measure of this. So I'm going to be able to fill in 3x for that angle as well. And the reason why I'm doing this is going to allow me to have more information inside of a single smaller picture, because we really like to work with just a single triangle if possible. So now I've used that information, but notice that here we have a 90-degree marking. Well, that's usually quite important, but I can't just take it and transfer it over to the other picture without making sure that I have a reason why. So I look for other markings that they tell me. And one thing that they tell me is that these 2 lines are parallel lines. That's really interesting, because if these 2 lines are parallel, I'm just going to extend them out, and we have our triangle formed with this being the right angle, and as this continues out, something like this, filling in those other angles. So I'm just mimicking the picture down here. If this is 90 degrees, then according to what we know about alternate interior angles, these 2 measures have to be the same. So if this is 90, this also has to be 90. So that means that this little angle right here in the corner is 90 degrees. That ends up being really useful because now I have one triangle with each of its vertices filled in terms of measure. So I can solve for x using the following formula. The sum of its angle measures is 180 degrees. So 2x plus 3x plus that 90 degrees in the corner has to equal 180. I can subtract the 90 from both sides, leaving me with 90 is equal to, well, 2x plus 3x is 5x. And that brings me all the way down to my final answer for x, which is 18. Now the question is, of course, going to ask for maybe a few other things, like finding this actual 2x, but I trust that you guys can do it from that stage. So let's move on to 38. 38 is a similar problem. Once more, what we're dealing with is a picture where we have overlapping triangles. And that means you're going to have to use every piece of information that you can to put together your formulas. Now, the first thing that I notice is that these two lines are parallel. And remember, as soon as we have parallel lines, we can do kind of what we did over here and find out which angles they have in common. So I'm going to kind of sketch this with just the parallel lines in it. And I'm going to focus on this 90 degree here because I want to see how that connects with the information I have on the other triangle. Well, I know that if I have a transversal coming through here, this line right here, that comes through at 90, well, that means that same side interior angles will also be 90 because these two angles have to add up to 180 since they are supplementary. So that means I know that this is 90. And in my picture, which looks something like this, I can then fill that information in. Whew, maybe yours looks a little bit neater than that. I can fill that in by transferring this 90 degree over to here. That ends up being really useful because look at how we have an x for this angle and a 1.5x for this angle. And those two angles together equal 90. So I can make a formula of 1.5x plus x is equal to 90. That's going to give me, well, 1.5 plus 1 gives me the 2.5x is equal to 90. Therefore, I know that just x is 90 divided by that 2.5, or 36. And from there, I can solve for any other angle in those triangles. So let's get to our final problem then, problem number 39. When we're looking at this one, don't forget that the square in the corner does, of course, mean 90 degrees. And I'm going to just, for now, mark the angles that I have. I have this 3x minus 2, I have this 90, and I have this exterior angle. Now, the reason why these markings are handy is because that's going to help me figure out what formula does this most match with. And what it really matches with is the formula for the exterior angle of a triangle. And the exterior angle D is going to be equal to the farther angles, the ones that are not connected to D, added together. So that means that my 7x plus 4, that exterior angle up here, will be equal to my A and my B, my 3x minus 2 plus my 90, those two angles. Now here I'm going to have to simplify and solve. So I end up with 3x plus 88 is equal to 7x plus 4. Subtract 3x from both sides and you end up with 4x is equal, and subtract 4 from both sides and we get 84. So I have 4x is equal to 84, which means that I have an x value of 21 when I divide 4 from both sides. Once more, I can use that answer to solve for any of the angles remaining simply by substituting in the 21 into those expressions. And that is the end of the primary questions I get. If there are ones that you still have questions on that are not in this video, feel free to send me a message, or if you are in person, you can just ask me a question by raising your hand and I'll help you out. Have a good day.